We're continuing our review about percents, number manipulation type problems. Everything we're looking at today is a story problem. So as the example gets started, obviously you want to write the example down in your notes. But if you do not have enough time to do so, make sure we pause the video, get it all written down, and then we'll be ready to show the problem. So our first example says, at a high school, 120 of the freshmen take biology. 40 freshmen do not take biology. What percent of all freshmen take biology? So to get a percent, anytime we're looking for a percent, we're going to take the part that we're looking for divided by the total. That's always going to give it to us in decimal form. And then change to percent. To change from decimal to percentage, we reviewed how to do that last time. We move the decimal point 2 places right. Basically, we multiply times 100. So again, to find a percentage, we're taking the part that we're looking for divided by the total amount, and then we need to change that to a percent. So what percent of all freshmen take biology? So we want the part that takes biology. 120 take biology. Divide that by the total. Well, we have 120 that take and 40 that don't take. So we have 160 total freshmen. And then change it to a percent. Some of these problems would be calculator problems, some may not be. This one probably would not. Divide the top and the bottom by 10 gives us 12 over 16. We're just going to reduce this fraction. Can divide the top and the bottom by 4. Get 3 over 4, which we may know what that is as a percent. Hopefully we know 3 divided by 4 is 0.75. And then we can change that to a percentage by moving the decimal point over 2 places. If we do not know that 3 over 4 is 0.75, you could divide it out. 3 divided by 4. 4 goes into 37 times minus 28 to bring down that next 0. 4 goes into 25 times, decimal points right there. There's our 0.75. Another way we could do it is to always change the denominator to 100. So times 25, multiply the top by 25, 75 out of 100 is our 75%. Any way we do it, we get that 75% of freshmen take biology. Example 2. Example 2 has 2 parts. Part A says a manufacturing company produced 800 total bolts and 30 defective bolts. We are looking for the percent of the bolts that were defective. 800 total, 30 defective ones. What percent are defective? Again, to get a percent, and as always, pause the video if you need to. To get a percent, we're taking the part that we're looking for out of the total amount. We are looking for defective. We have 30 defective bolts. Total this time is given to us, 800 total bolts. 30 divided by 800. And again, a lot of times you'll be allowed to use a calculator. 30 over 800 is 0.0375. 0.0375. And then we do want to change this to a decimal. We change to a decimal by moving that decimal point 2 places. 3.75% are defective. Part B is almost an identical problem. It's a copy and paste outside of this word right here. So this 800, instead of being the total number of bolts, this time it tells us that the manufacturing company produced 800 good bolts and 30 defective bolts. We are looking for the percent of the bolts that were defective. So again, we're thinking through part over total. You could write it down. You don't necessarily have to. The part that's defective, that's 30 of them, out of the total. I have 800 good ones and 30 defective ones. So my total this time is 830. And we do our division, 0.03614. Move the decimal point 2 places, 3.61%. And problem typically, if it needs you to round, we'll tell you what to round to. Let's round to the nearest hundredth of a percentage point. Example 3. Example 3 says the James family eats at a restaurant where their bill is $84. They plan to leave a tip of 20%. What is the total amount due? James family eats at a restaurant. Their total bill is $84. They want to leave a 20% tip. We need the total amount that they're going to wind up paying. So let's think through what this tip is. The tip is going to be 20% of 84, right? The amount that they leave for the tip, they want to leave 20% of 84. Remember we said that when we are taking a percent of a number, first of all, the percent always needs to be a decimal. So we're going to take our decimal point, we're going to move it 2 places to the left. So 0.20. For the word of, we multiply 84. So we take 0.2 of 84. This one quite possibly could be no calculator. We can multiply this without. I get 16.8. So the tip amount is $16.80. We always want to be careful. We want to make sure we're answering the question that's being asked. If it said, what is the tip? There's the tip, $16.80. It doesn't ask that. It asks, what is the total amount due? So we have to not only pay the tip, $16.80, we're also paying for the $84 that their bill was. So we want to take $16.80 in the tip, add that to $84, and we get $100.80. $100.80 if they plan to leave a tip of exactly $20. Real quick, that's if your bill is $84 and you want to leave a tip of about 20%. Quick way to do that is to take 10% of that. 10%, we just move the decimal point 1 time. So 8.4, and then double it is 16.8, and there's your tip. That's if you're leaving 20%, which is pretty typical. Example 4. Example 4 says a car is priced at $18,000, but then it's being discounted by 10% this weekend. What is the discounted price? Car is priced at $18,000. They're taking 10% off this weekend. What's the new price? So we want to start by thinking through what the amount off is. How much are we taking off? Well, we're taking off 10% of 18,000. 10% of 18,000. 10%, I'm moving the decimal point 2 places. That's 0.10. Of means times 18,000. We just said to take 10% of something. We just moved the decimal point 1 place. So that's going to be 1,800. You could multiply it out if it's no calculator. This one would probably be no calculator. You could multiply it out. 3 zeros, 8, 1. 1 decimal point in your answer. So the amount that we're discounted is $1,800. So we need to start with 18,000, and we are taking off 1,800. $16,200. So we take 10% of 18,000, and this time, because it's a discount, we're lowering that price. We're starting with 18,000. We're taking 1,800 off of the amount that was given. A couple more example problems here. Example 5 says, when she was hired, Mary was paid $900 per week. She received a 20% raise, followed by a 15% raise. What is her new salary? $900 per week at her job. She got 2 raises, a 20% raise, and then later she got a 15% raise. We want to know, what is her salary now? Very first thing is we need to break this apart into 2 parts. She's getting 2 raises. We need to take care of them independently. This 20% raise we're going to take care of, and then we're going to do a 15% raise. I cannot add these percentages together and say that she got a 35% raise. And we'll take a closer look at why here in a little bit. So let's start with the 20% raise. To give her a 20% raise, right now her salary is $900. And I want to increase her salary by 20%. So I'm going to multiply that by 20%. We're going calculator problem on this one. So 900 times 0.2. Her raise is $180. So her new salary, she was at 900, we're adding 180, so now her salary is $1,080 per week. Now we need to give her the second raise. Now we need to give her the 15% raise. Well, right now her salary is $1,080. And we need to increase that by 15%. So real quick, this 15% raise is on her new salary. We want to increase 1,080 by 15%. If you just added these together and gave her a 35% raise right from the start, This 15% raise would be on this $900. We want to give the 15% raise to what her new salary is. So 1,080 times 15%, 0.15. This time she's getting a raise of $162. That's her raise. Her salary was $1,080 plus the 162 raise. She is now being paid $1,242 per week. And that is her final salary. $1,242 is her new salary. Notice if I had just taken 900 and given her a 35% raise, that's her raise amount plus the 900, 1,215. Notice it's less. It's less because this 15% should be on her new salary. She would just be getting 15% of that $900 the second time had you just added them together. You cannot just add percentages together. Last example, example 6. Says sales tax in a state is 10%. The price paid for an item after the sales tax is $170. We want to know what the original price of the item was before applying the tax. So we paid $170. That includes 10% sales tax. We need to know what was the original price of the item. So we want to take the price of the item. Notice when we've increased stuff on other things, like here, we wanted to increase this number by 20%, right? So we took this number, 84, we took 20% of it, and then we added that amount to 84, right? The problem is, here, I don't know what the original price is. This is unknown. That's what we're trying to figure out. So let's call that X. That price is X. And then I need to add on 10% of that original price. I need to add on 0.10x. This is the amount you pay in sales tax. If I take the original price plus 10% of the original price, I know the final amount here is $170. These are like terms. I can combine those up. I have 1x plus 0.1x, that's 1.10x. And to solve for x, we divide both sides by 1.10. Calculator problem here for sure. And I missed something there. 170 divided by 1.1. Golly, I missed the decimal point that time. 154.55. Round to the nearest cent. $154.55. Again, we want to make sure that we are answering the question asked, what was the original price? I made X the original price, so yes, there it is. If it wanted to know how much did we pay in tax, you would take 10% of that, and this is the tax. This is original plus tax is total. We're looking for original, so we want 1x. If it wanted how much is the tax, you would take 10% of that. That's it for the notes.